Okay, everybody, we're doing the exponential growth and decay now. So this was the next day's lesson. This was April 22nd and April 23rd. And exponential growth and decay is very, very similar to compound interest. It's actually the same exact formula, except instead of using P, let me see why it's not working. Well, okay, maybe I have to use my pen. That's fine. Instead of using P, they're using Y, but you can use P if you prefer. So Y equals, we're going to say our initial amount, this time P is standing for population usually, but it can mean whatever the initial amount is, still times, parentheses, 1. Now growth will be a plus, but decay will be a minus. So in this case, you have to really read the problem and see if it means that the problem is going up or down, because that's going to change what's going to be in the parentheses here. Still the R value written as a decimal, not a percent. Close it, and then the exponent, which I'm using a T, but you can use an R if you prefer. So it's the exact same formula as compound interest. The only change is when things are going down or there's decay, you're going to have a minus here. The good thing to remember, though, is sometimes they're going to write this not as 1 plus R. They'll actually do the math for you. So say you see 1 plus 0.05. That's the same thing as 1.05. So if you see in a problem 1.05, that's going to indicate that there was a growth rate, because in order to get 1.05, you had to do 1 plus 0.05. The same thing happens with like 1 minus 0.03 or anything really. They might just write that as 0.97. So if you see 0.97, that's a decay because they had to subtract in order to get that number. And you're going to see that in the form. You might see a problem and they'll say, is this growth or decay? The way to do that is to look at what was inside the parentheses. If it's greater than 1, it was growth because they had to add to get there. If it's smaller or less than 1, it's decay because they had to subtract it. Ready to do some problems? Okay, here we go. So, an art museum has a painting that's worth $12,000. That's going to be our P of 0, P sub 0. It's our initial amount. The museum expects that its value will increase. So increase means I'm going to be using the plus. It's going to be growth by 5%. And we said we have to put that as a decimal. So you move the decimal place over twice, you get 1.05. I didn't even know I was doing that. Here we go. That's the one I did over here. And that's it. So I've got my P of 0, I've got my plus, and I've got my R. So I have enough information to write the formula. Is this an example of exponential growth or decay? So this one right here is growth because it said increase. If it said decrease, it'd be decay. Write an equation that models the value of the painting. So Y equals our initial amount, which was in this case 12,000, times parentheses 1 plus our R value, which is 0.05, close it to the T. So writing this function or this equation is just like writing the equation for compound interest. Now what we're going to do is we are going to find the value in 4 years. So 4 is time. I'm going to be putting that 4 where the T is. Y equals 12,000 times 1 plus 0.05. And then the 4 will go up in the exponent. We need to go to Desmos or our graphing calculator, whatever one you're working with. I'm going to work in Desmos. So here we go. And I'm going to type this in. You can put y equals, but you don't have to. That's optional. I'm just going to go and I'm going to do the 12,000 times parentheses 1 plus 0.05, and it was 4 years. So I'm doing shift 6 to bring it up. I'm putting that 4 in. We were talking about money here, so we can have 2 decimal places because the painting was measured in dollars. So I've got $14,586, and that will be 8 cents because the 5 will bring the 7 up 1. So 14586.08. 14586.08. I'll put my dollar sign. So that's the answer. That's how much it will be in 4 years. So that was exponential growth. So now we're going to do an exponential decay. Same exact formula, except when we decay, instead of adding, we are minusing, we're subtracting because it's going down. So we have a population of a city. So population means we're talking about people. So when we write our final answer here, we're not going to have any decimals because people are full numbers. So the population of a city was 160,525. That's going to be my P of 0. It's my initial amount in 2005 and was decreasing. So that's minus at a rate of 1.5%. And remember, we're moving the decimal place over to the left twice. So 0.015. Growth or decay. So this one is decay because it's decreasing, so it's going down. Write an equation that models the population of the city. So we're going to say y equals our initial amount, 160,525. I could put the dot into there, times 1 minus, because it's decay, 0.015, and I'm still putting my t up in the exponent. So the only difference between this problem and the problem before was now it's minus because it's going down, it's decreasing. Last problem. So use your equation to calculate the population in 2010. This is where it gets tricky. That's why I underlined the 2005 up here. So usually we're used to seeing them say in 4 years or 10 years or 5 years or whatever. In this case, we have to figure out how many years passed to get from 2005 to 2010. So you're going to do subtraction. So 2010 minus 2005 gets me 5 years. So that's going to be what my t is. So we're going to put a 5 in for t. Whoa, I don't know what that did. Please go away. Okay. Y equals 160,525 times 1 minus 0.015 to the 5, because we said 5 years passed. So if you have your graphing calculator, if you have your TI, you're going to go into that and you're going to enter all this in the same line on the main screen. But if not, we're going to go to Desmos. I'm going to clear out this one, and I'm going to type in my equation, 160,525 times parentheses 1 minus 0.0125 to the 5. And I'm just going to check to make sure I got that right. Odd numbers, 160,525, 160. 0.0525, 1 minus point, oh, see, I made a mistake. 0.015. To the fifth. So right here, we have our answer. And we said that this is people, so I'm not going to use any decimals. I'm just going to say 148,841. That is a beautiful number, if you know what I mean, because it is such a kind of, okay. Sorry, it's just mathing. 148,841. Like if I wrote a line down here, see how they're, okay, look it over it. People. Okay, and that's it. That's how we do exponential growth and decay. Remember, if you still don't understand this topic, you need to reach out to your teacher and we can help you some more. Talk to you in the next video.